Hello students, let us try to understand the first law of thermodynamics. What is meaning of the first law of thermodynamics? That is the in the simple way we try to explain the first law of thermodynamics is the energy can neither be created nor be destroyed. You know, uh, but in the way of the chemistry, let us see it is impossible to construct perpetual motion mechanical of first kind of that can work without consuming any form of energy. Okay, so without consuming any form of energy you cannot do any work. Okay, so or the net energy change in the closed system is equal to heat absorbed plus the work done by the system. So whatever the energy change is energy change of the system is equal to, that is how much the heat is being absorbed by the system and the work is done by the system. So this is what the definition is, exact definition. The net energy change in a closed system is equal to heat absorbed plus the work done by the system. Okay. So next one, mathematically, how can we formulate the first law of thermodynamics? Internal energy, change in internal energy equal to Q plus W. Okay. So Q is the heat absorbed and W is the work done by the system. If the work is done on the system, so positive W will be negative. So positive sign means what, student? That is work done, on the system. Let us see what is delta U, change in internal energy. Q is heat gained or lost by the system. W is work done by the system on the system. Okay, or on the system. Okay, here for absorption of heat, Q is positive and release of heat, Q is negative. And what is the sign with the W? Here you see for the better way. If work done on the system, then delta U will be 0. A heat flow from the system to surrounding. Okay, if work, they are saying if the work is done on the system, then internal energy will be 0. Okay, in cyclic process, delta U and Q, delta U is equal to 0, Q equal to minus U. Net work done by the system is equal to net heat absorbed. In an isobaric process, delta P is 0, so Q is equal to delta U plus P delta B. So QP is equal to delta H. In isochoric process, delta V is 0, that is Q is equal to delta U equal to QV. What are the application of first law of thermodynamics? When W equal to 0, when the W equal to 0, so internal energy, change in internal energy is equal to heat absorbed, that is del U is equal to Q. If heat is absorbed by the system, if heat is absorbed by the system, internal energy increases. If heat is lost by the system, internal energy decreases. Okay, in adiabatic condition, when Q is equal to 0, okay, so adiabatically U is equal to internal energy is equal to W. If work is done on the system, internal energy increases. If work is done by the system, internal energy, okay, if work is done on the system, internal energy increases. If work is done by the system, internal energy decreases. In adiabatic process, work is done by the system at the expense of the internal energy. In adiabatic process, work is done by the system at the expense of the internal energy. That is, T initial will be greater than T final. Isothermal. When the delta U is equal to 0, Q is equal to minus W. So isothermal process, heat absorbed by the system is equal to the work done by the system, is isothermal process. We can write W is equal to minus Q. So this was the first law of thermodynamics. Again, I am concluding the first law. So first law, they are saying we are having the internal energy. Okay, change in internal energy we are studying, and changing internal energy is what, that is heat absorbed by the system, that is Q, and that is work done on the system, that is W. So internal and change in internal energy is equal to sum of the heat absorbed by the system and work done on the system. or work done by the system. Each work done by the system, here sign will be negative, and if work is done on the system, the sign of the W will be positive. So here you see, student, that will be much better. Delta U is equal to Q minus W. So see here, negative sign, what they are saying, work done by the system. So work done by the system, loss of energy, so that is negative sign. Q is heat added, and change in internal energy is delta U. If the second point, what is the first law of thermodynamics in chemistry? The first law of thermodynamics state that energy can be converted from one form to another with the interaction of heat, work, internal energy, but it cannot be created nor destroyed under any circumstances. Mathematically, delta U is equal to Q plus W. So here is Q is heat, W is the work done on the system. Some example, let us try to understand. A gas has constant pressure in a system. There is a loss of 45 joule of heat in the surrounding around the system. So 450 joule of work is done onto the system. Find the system internal energy. Okay, find the system internal energy. So delta U they are asking. So you can apply the first law of thermodynamics, that is delta U is equal to Q plus W. And here is, they are saying Q, how much heat is, heat is lost 45 kilojoule. 45 kilojoule means the positive 45 joule. And another thing, 450 joule of work is done onto the system. Done on the system, that is positive sign, that is 450. If you add it out, it will be the 495 joule. So in general, if you want to find out the internal energy, which is denoted by delta U, is important, consider the relationship between the surrounding and the system. We already know, according to the law, that energy is neither created nor be destroyed. Thus, we can tell that anything that is lost by the surrounding will be gained by the system. Moreover, the surrounding area will lose heat and carry out some work onto the system. So if you look at Q and W, they are positive in the equation, and this is the mainly due to the system gaining some heat and work being done on the system. So that is quite easy problem. Next problem, find out the internal energy of a system which has a constant volume and the heat around the system is increased by 50 joule. So Q is equal to 50 joule. And next one, they are saying, since the gas is constant volume, delta V is 0, so the W is equal to P delta V equal to 0. The equation for internal energy delta U is equal to Q plus W. So delta U is equal to Q. So delta U is equal to what, student? That is 50 joule. Okay, so correct option is that. Now, no, the first law of thermodynamics state that the change in internal energy of the system equal to the net heat transfer into the system minus the net work done by the system. In equation from the first law of thermodynamics, delta U is equal to Q minus W. Negative sign means work done by the system. By the system, so negative. On the system, we already explained, if it is on the system or previously it came, so on the system means it will be the positive sign, but by the system it will be the negative sign. Okay. How is the first law of thermodynamics calculated? So the first law of thermodynamics is given as delta U is equal to Q minus W, where delta U is change in internal energy of a system, Q is net heat transfer, the sum of all heat transfer into and out of the system, and W is the net work done, the sum of the work done on or by the system. So here is delta U is equal to Q minus W. So minus sign is what, work done by the system is there. So that is negative sign. Okay. Here also you can see the mostly you can understand negative sign here, better explain, work done by the system, heat added to the system. The change in internal energy of the system is equal to the heat added, heat added to the system and work done by the system. Okay, so these were all about the first law of thermodynamics. I hope it will be little bit helpful to you, student. Thank you so much for watching.